Assalamualaikum, kids from Madrasah Al-Junid. I'm Mr. Faris, and today I'll be going through the remaining corrections for the prelim paper, which is prelim paper 2. Yeah, and we have question 8 for this question. You can flip over here and we can begin. So let's start. ABCD is a parallelogram, all right? So immediately you know all the opposite sides are equal. So for example, AD equals to BC, AB equals to DC, so on and so forth. And we start off by them saying that DA is 5 cm. So DA is 5 cm. And AB is x plus 3. And after they also say that AE is x cm. Just interesting. So the AE is x cm. Parameter ABCD is 24 cm, so the whole thing is 24 cm. So what we can actually write even before I begin the question is that since AD equals BC, this length is also 5 cm, and this whole thing here is also x plus 3 because it's a parallelogram, the opposite sides equal. So we actually can find x almost immediately because we're going to need it for the rest of the question later on, I believe so. You can write down x plus 3 plus 5 plus x plus 3 plus 5, and this gives you 24. 3 plus 5, 3 plus 5, and 2x. You get 2x plus 16 equals to 24. 2x equals to 8. X equals to 4 cm. Right? So great, you have already found x. And AECF, apologies for blocking this. AECF is a square. Okay, so inscribed in the parallelogram, so it means it is fully inside of where the edges are touching. So this is square, so we know this is the square here. It's inscribed in the larger parallelogram there. So we know all of these are 4 cm because we found x as well, and all these are x. Great, and we want to find for question A the area of parallelogram of ABCD. What you need to notice is that, firstly, is that the formula for the area of parallelogram is actually just base times height. So the common question we get is, of course, who is the base and who is the height? So if you look over here, this is actually the base, and this will make EC the height. Why, you ask me? Because over here is 90 degrees, because AECF is a square, right? So over here, this is your base and this is your height. So what's the base? It is just, let me write the letters first, is DC times EC. Sorry about that. It is DC times EC, very easy. So what is DC? We know that this is x plus 3, so it's 4 plus 3 cm, and EC is our x, which is just 4 cm. So you get 48, my apologies, you get 7 times 4, it's 28 cm squared. Alright, next, let's look at the second question, question B, angle DAE, right? So I'm going to focus on just one part here, which is actually our DAF. So I'm going to draw here for question B. Of course, when it comes to trigo, it would be nice if you can redraw. But when you redraw, you try to make it friendlier, because if you look at this triangle DAF, my apologies, it's a very thin triangle, so I increase its width a little bit. It doesn't matter because you are redrawing, you can neutralize the difficulty of the question here. And this is 90 degrees because of the square over there just now. And we have 5 cm here. And if you look at DF, right, and all the way here, this is C, we know for a fact that this is x plus 3. And we know that FC is x cm. So what's happening here is that DF itself is just 3 cm. Right, great. And over here what we have is actually a right angled triangle, like so. Okay, and if you want to put into perspective, E is all the way here. Right, so we're interested to find this angle. So what's the way forward? You have to find this tiny angle called DAF and you add in your 90 degrees. Right, so that's the problem with this question. A lot of you only found DAF, but you did not add in the 90 degrees. So let's get started. For angle DAF, you have your opposite and your hypotenuse, because the 3 cm is opposite that particular angle. So you can write down opposite and hypotenuse reduce, you use sine. So sine angle DAF, apologies, DAF equals to opposite over hypotenuse. You can find angle DAF, which is just sine inverse 3 over 5. Let me just use my calculator. Sine inverse 3 divided by 5, and this gives you 36.86. Just don't need to round off this answer because you want to use it in 2 dp to round off to 1 dp as your final answer. So finally, you have to find angle DAE. What do? You need to add in your 90 degrees. So 36.86 plus the 90 degrees that we have from our square, and this gives you 126.86. And it's here, then you round off to 1 dp. 126.9 degrees. Right? Question A and B for question 8 done. Let's go to the next question. Question 9. Let's look over here. Let's put some over here. Of course, at any point of time, you can just pause the screen to copy, so you don't have to tell me to slow down or anything like that. Okay, find the equation of the line of the graph L. So this is a line we're interested in. Let me just change the color a little bit because so this line L. Okay, it's a cursive L. That's how we denote this particular line. Like so. Next, we need to understand that it consists of two parts. That is the equation of line, y equals to mx plus c. The unknowns being m and c. M is your gradient, right? But for the current question, you get your c for free. What is c? C is actually the y-intercept. And where in this diagram you get to see the y-intercept? It's over here. The y-intercept is where the line cuts the y-axis. So we know for a fact that the equation of the line is mx plus 1. Because it cuts the y-axis at 1 over here. Right, next, you have to find m. You have to find m, you have to use the formula y2 minus y1 over x2 minus x1. Okay, so where do we get these values for y2 minus y1, x2 minus x1? You can choose any points on the graph itself. So choose two nice points, one over here and one over here. Right, hang on for a bit. So you choose these 2 points, you label them with the coordinates. So it's x followed by y. In this case, it's -1, 2, and this is 2, -1. So you can choose any of them to be the second point or the first point. So let's choose this to be a second point, and this is a first point. So it's y2 minus y1, y2 minus y1. Let me just get rid of extra y. Yeah. And this is our x2, and this is our x1. You take -1 minus 2 over 2 minus -1. And what do you have? Minus 3 over 3, you get -1. Okay? So now your equation for the line L is y equals to -1x plus 1. So this is what a lot of you wrote, -1x plus 1 or something to that effect, but most of you got it wrong because of the y-intercept or rather. It's actually just -x plus 1. Right, Ken? So don't write the extra one or the redundant one over there. So that's for question A. Question B. A student claimed that the graph K with an equation y equals x minus 2 does not pass through the graph. Is the student correct? Explain your answer. Alright, there are many ways to do this. So they call it a graph. Usually you call it line, but doesn't matter. So for question B, you can write this down. M of the line L does not equal to M of the line K. Alright? I repeat myself, the gradient of the line L, the first and origin line, does not equal to the line of the new graph, which is labeled as K. Why is that so? What is the gradient of the second graph? Let's look at line K. It has an equation called y equals to x minus 2. What is the gradient? It is a coefficient of the x value. So it's actually 1x minus 2. So in case you want to note yourself, the gradient from the original line, which is line L, it is +1. Apologies, it's -1. And the gradient for line K is 1, as what we have seen here. Alright? So what's going to happen? They are not parallel. Why? Because if two lines have the same gradients, they are parallel. This is the only case where they do not meet, which means that the same gradient. there's another condition which I do not know which to mention here, but it's good enough for now. So once they have the same gradient, they are parallel. And therefore they do not meet. So if you look at this statement, it's saying that they do not have the same gradient. Therefore, use their words, graph K and graph L are not parallel. And graph K, just use a student statement, graph K will pass through graph L. And is the student correct to answer? Therefore, student is wrong. The student should have listened in class. Next, by drawing the graph K on the grid above, find the area of the shape formed by both graphs M and K. Okay, I believe there's a typo here. Graphs L and K and the y-axis. Right. So when you're asked to draw a line, so we're going to use this equation because it's graph K. You have to generate a new table. Okay, so 3x and y. And the minimum number of values to put out is actually just 3. There's no need to draw like 8 points to draw a curve. It's just 3 points. Let's choose some values, simple ones. 0, -2, and 3. Is it possible? 0, -2, and 3. Let's try 1 instead. The reason why I chose this set of numbers is that I don't need to worry about them being order. Right, so long as they're within the range and they produce y values that are within the range as well, it is good enough for us. So let's substitute inside. Keeping in mind that the equation is y equals to x minus 2. Right, I'm going to change one value, so I do apologize. I'm going to put here as 3 and minus 1. 3 and minus 1, does it work? 3 and 1, I think 3 and 1. Okay, so you have to substitute in the values. For the first one, it is y equals to 0 minus 2. The second one is y equals to 3 minus 2. The third one is y equals to 3 minus 1. And here you have the values, minus 2, 1, and minus 2. And 2, my apologies. And 2. What am I writing? Not 2. It's not 3 minus 1. It is 1 minus 1, so it's 0. Because it's x minus 2, 0 minus 2, and 0 minus 2. Oh my goodness, what's happening with minus 2, right? Sorry for the mix-up. Right, so it's x minus 2, x minus 2, x minus 2. And these are the values of x you're going to put inside. I do apologize for that. And of course, you don't get a 0, you get a minus 1. Okay, so what you can do, I can plot in the Cartesian plane 0 minus 2. Where is 0 minus 2? 0 minus 2 is over here. This is our y-intercept for that line. Next, 3, 1. 3, 1 is over here. And the last one is 1 minus 1. 1 minus 1 is over here. And you can draw a straight line like so. So eventually you can see that they cut at, right? And what are they interested in? They're actually interested in a particular area of the shape formed by both graphs L and K and the y-axis. This graph L, this graph K, and the y-axis. So I'm going to now take a screenshot quickly. Just much more convenient to write on the whiteboard. So what area are they interested in? Basically, they're interested in, option C, this particular area. Over here, here, and here. The two graphs and the y-axis. So we are going to go very simply using our base times height. This is the base and this is the height of the triangle. What is the base? You can count. This whole thing is 1 actually. 1, 0, -1, and -2. So what is the value? It's actually 1, 2, 3. It is 3 units. And over here, for the height, it is 1.5 units. Okay, let me just redo everything here again. I'll repeat again. The triangle you're interested in is over here, like so. Okay, and the height is over here, and the base is over here. Let me just highlight that in a different color. Base times height. Now, what is the base again? The base is the base is 3 units, and the height is 1.5 units. Okay, and then 90 degrees like so. So you can find the area that you require. Area equals to half times base times height. Right, you get 2.25 units squared. Right. For next question 10, I'm going to skip. You can refer to answer key. I'm going to focus on question 11. So let's run through this. Find angle BAD and give a reason for your answer. Where's BAD? Over here. Right. For those who are struggling with this topic, every time you do corrections, I really request that you actually write or draw the setup for the particular rule. In this case, I have a circle. And the rule that we're interested in is just the following. It's fine. Like so, this is 122, and this is our 61. That's where I find BAD. So you can write it down. Angle BAD is 122 over 2 equals to 61 degrees. Of course, you have to write reasoning because they really explicitly request it from you here. Every time you see this particular setup, the reason is angles at center equals 2 times angle at circum. Okay? Right, next. Find angle BCD and give a reason for your answer. For the second question, you need to do this, draw a circle again and do the other setup here. This is 122, but I need you to understand that if this is 2x, this is actually x. It's a setup, and you use the same reason actually. The focus of this particular setup is actually this angle here and this angle here. Right, nothing to do with 122. Of course, you need 122 to solve the part, so you have to find angle BOD first. But you've realized 122 is angle BOD. So how do you reference the angle as outside? So we say reflex angle BOD equals to 360 minus 122. And this gives you, hold on, 238 degrees. Okay. And how do we find angle BCD? Excuse me. Angle BCD equals to 238 over 2 and gives you 119 degrees. And the reason for the first one is angles at a point. The second one is angle at center equals 2 times angle at circum. Right? Next, find the length of BD. Very interesting question, but for this question, you can actually just draw the setup again of triangle ABD. Because you have enough information for triangle ABD in this question. You have your 3.6, you have your 4.8, and the angle in between as well, which is what we found to be 61 degrees. So how do we find BD? So if you recall this setup, first of all, there is no angle length pair. You don't have this length, but you don't have this angle. You have this particular length, but you don't have the angle here, so on and so forth. And you have this angle, you don't have this length. So you know you cannot use sine rule because there are no angle length pair. And of course, not all three sides are given, so you can use inverse cosine rule, and you're left with, of course, your cosine rule. When you apply cosine rule, it's faster for you to just apply for square root. So let's begin. BD equals to, and go all the way to the end and write cosine 61 degrees. And the rest you can fill up quite haphazardly. Plus 4.8 squared minus 2 bracket 3.6 bit 4.8. Alright. Let's calculate this. 3.6 squared plus 4.8 squared minus 2 times 3.6 times 4.8 cosine 62. 61. And what do you get? 19.244. 19.244 rounded off to 19.2 cm. Alright. Next, find the length of the radius of a circle. This is a very interesting question. I need to narrow down an idea for question D. There are many ways to do this, but there's one I need to focus on is a triangle called OBD or BOD, what we have previously. If you look at this particular diagram, you realize that BO and OD are the radius. That's why this is an isosceles triangle. So OBD. And we have our length, it is 19.24. And these are the unknowns. Let's put it as R, because that's what we interested to find. R and this isosceles. And of course, you have the angle here, which is 122. There are many ways to do this. Why? Firstly, you need to understand that there is an angle length pair. The angle followed by its length is opposite. So you can use sine rule. But we don't have any other angles, or do we? Well, we have actually. We can find any one of these. So how to find angle OBD? It is just 180 minus 122 and the whole value divided by 2. You get 29 degrees. So once you have this angle here, 29 degrees, you can use it to find the radius. So what's the fastest way to find the radius here is to use the original sine rule formula, where sine is below. Sine 29 degrees equals to the known pair, which is 19.24 over sine 122. And if you recall why we do this, it's because we can cross multiply very quickly. 19.24 sine 29 all over sine 122. Just do that. 19.24 sine 29 degrees divided by sine 122, and you get 10.999. 10.99 rounded off to 11.0 cm. Keep in mind you have to have 3SF, so 11.0. The 0 at the back is a significant figure. Next question. Some of you tried to do this question, but I have not particularly went through probability. So probably I'll try to hint when we're doing our work that we also try not to do this question 12 kind of question if you're given a choice. Anyway, let's quickly run through it. A bag contains 6 blue balls, 5 red balls, and 4 white balls. So altogether there are 16 balls. Excuse me, there are 15 balls altogether. 15 balls. And they want to calculate the probability that the 2 balls are of the same color. So you need to write down the condition or the successful event or the favorable event, P same color. That's what they want. Because if P different color, you have to go doctor. Anyway, P same color. So you have to interpret P same color, which is actually our BB or RR or white. So these are the ones you get same color, and they are, of course, you're picking up 2 balls after all. But you need to understand something. While these are all, you need to understand how you read this WW. WW means W and then W. So it's quite good that Singaporeans like to, or Singaporean kids tend to run off in sentences such as, today I do this, and then I do this, and then I do this. So here you naturally have the and. It's very important to consider this a conjunction, because and will remind you that it's times, whereby or, like these two here, is going to be plus. So you can have a quick summary that and is times or is plus. Alright, so how do we get our first blue? You get our first blue by taking 6 balls, I think any of the 6 balls out of 15 balls, multiplied because it's an n, remember, blue and then blue, and it's 5 balls left out of 14 balls. Are we clear? Then these are BB, so plus RR, same working, 5 out of 15 times 4 out of 14 plus 4 out of 15 times 3 out of 14. Why is this 14? Because you have taken one ball out before that, right? For example, another point. Why is this 3? Because you've taken out one white ball and the second white ball is only out of 3 different white balls. Alright? Okay, let's get started. 30 plus 20 plus 12 divided by 15 divided by 14. And this will give you 31, 105. Right? That's it. Next, Ayesha recorded distance in kilometers. She drove in 120 car journeys. The results are shown in the cumulative frequency graph below. The median, right? I'm not a big fan of this particular graph, but we can try to do it. The median is actually the middle value. But for a cumulative frequency curve, there's no need for you to plus 1. So first of all, you find the middle position. The middle position is actually the 50th percentile, which is just half of it. You can take 120 times 50%. This will give you the 60th position. So you can go to the 60th car, or the 60th car journey, my apologies, and you can just draw a line and all the way down. I believe there's some, you can agak, right? So I'm looking at 56. You want to get 56? Yeah, 56-ish kilometers. Okay. So part 1 is 56 kilometers. Next, part 2, the interquartile range. To find the interquartile range, you need to understand it consists of 2 parts. It's Q3 minus Q1. Q3 is your upper quartile, which is actually your 75th percentile. Q1 is actually your lower quartile, which is your 25th percentile. Right? So we can quickly do some working. We take the total number of students of the car journeys, my apologies, and multiply by 75 over 100, and you take 120 times 25 over 100. Actually, if you are quick enough, you understand that this is just 90, the 90th car journey, and this is the 30th car journey. Right? 1/4 and 3/4 of the way. So let's quickly run through our upper quartile. Where is the 90? It's between 180, so it's here and here. Oh my goodness, it's quite difficult. Right, I see now. So it's around 1, 2, 3, 4. It's only 4. You just tell count. 1, 2, 3, 4. Oh, so odd. Okay, anyway, let's just draw all the way here at our 90th position. And this is our, and you can draw downwards. We'll take it as 67. Do it vague. And 30 is over here. We'll take it as 46. So our Q3, Q1, we take Q3 to be 67 and Q1 to be 46. So you can take 67 minus 46. 67 kilometers minus 46 kilometers. And this will give you 21 meters, 21 kilometers. Okay, next. Percentage of the journeys greater than 50 kilometers. I can cheat a little bit. I just erase everything to get the question started again. So what you can do for this particular question, you have to draw a line up from 50 kilometers, right? And you realize that there are 80, oh, so ugly, so embarrassing. There are 80 car journeys that are more than 50 kilometers. Because it's a 50 kilometer. And if you draw over here, all these car journeys, they are more than 50 kilometers. Are we clear? So it's actually 120 minus 40 gives you 80. So write down. Percentage required. It is 80 over 120 times 100. You get 66.67. 66.66 is recurring. Round off to 66.7%. Alright, I'm going to zoom out. Yeah. This is our part 2 answer. Part 1, part 2. That's it for now. Hope to see you guys soon. Wherever I see you. Take care. Bye.